Alright everybody, hello, this is Mrs. Johnson here, and we are going to be talking about some radical stuff today. So just wanted to let you know this is the next page of your notes packet, so if you would like to watch this video on your phone and maybe take some notes into your iPad, that would be fine, or if you're more comfortable watching it on a desktop in the media center or at home, that would be fine. Or you can just watch and see what happens, but I want to let you know that all these examples are actually in your notes packet, so if you want to kind of rearrange all your stuff so that you can copy some of this down, go ahead and do so now. But anyways, what we're going to do is we're talking about R.7, some radical stuff, so I'm going to give you a couple vocabulary definitions here. So the first word is index, and this is the number in front of the radical. So what you need to understand about numbers in front of radicals is that you guys already know what a square root is, but it actually has an index of 2. And similarly, it should make sense that a cube root has an index of 3. And so maybe something that you haven't really heard of or kind of thought about before, but a normal square root, what I'll refer to as this one, like the radical 108, there's actually kind of an imaginary 2 hanging out in front of here, but you don't really write it. But you know that when you break down radicals, you look for groups of 2. So if you remember how to break down radicals, 108 is 54 and 2, and 54 breaks into 9 and 6. 9 is 3 and 3, and 6 is 3 and 2. It's a 3, by the way. And so remember, all you're doing, this is kind of basic elementary breaking down radicals. What I like to do is circle the groups of 2. So there's a 3 that comes out. Remember, it's not 9 that comes out, it's the group of 2. And you just write 1, 3 on the outside. Same thing, there's a group of 2 2s. So that 2 comes out. And then you got to be careful because the only thing that's left over on the inside of the radical is this 3 that didn't get circled. So if we're going to break down this radical all together, let's see, I need my eraser. We're going to break down this radical all together. We're going to bring the 3 out and the 2 out, so there's actually a 6 on the outside, and the 3 that didn't get circled stays on the inside. So that's a review type of problem of something that you've already done before, but maybe just need a little refresher. But now let's talk about this cube root here, this 81. We're still going to break it down the same way, but the fact that it has a 3 in front means that you can only circle a group of 3. Okay, so I'm going to break down the 81 the same way. You all know that 81 is 9 times 9, and there are other ways to break them down, but you'll still have it simplified the same way if you follow the same process. 9 breaks into 3 and 3, and here is another 3 and 3. So since I have a 3, my index, new vocabulary word, is a 3, what I'm looking for is circling a group of 3. So here are 3 3s. That's what gets to come out. So my answer is going to be a 3 on the outside. You do have to keep the radical the same, so you need that little 3 because it's the same exact radical through the whole problem. But this 3 is the one that stays on the inside. Okay, so depending on what the number of the index actually is, that's the type of groups that you're circling when you're breaking down your radicals. Okay, going back to converting between forms, what we talked about last week, which is what we're going to kind of expand upon here, is what when we introduced what x to the 1/2 meant. Do you remember it looks and sounds totally different than a square root, but they mean the exact same thing. Remember we talked about how they're just written in different languages. And similarly, you have x to the 1/3. That's a cube root of x. And so it actually works for any type of fraction that you have on x. And what you have to remember is top in, bottom out. And so what that means to me, you'll hear me kind of saying that a lot. The top number of the fraction goes inside the radical. That's what top in means. And then the bottom number of the fraction goes outside the radical, meaning it is the index. Okay, so top number in, bottom number out. So these examples down here, what we're going to do is we're just going to practice converting. So we're not simplifying. Basically what you're doing is you're all probably in some kind of a foreign language class. You're translating x to the 1/3 into radical language. So right now it's an exponent language and you are just doing a translation. So remember, a 1/3 exponent just means the cube root of x. And that's it. So we're just converting. Y to the 1/2, you already know, means the square root of y. And so now x to the 2/3. So if you remember, top in, bottom out, the x goes inside the radical, and this top number goes inside the radical as an exponent, and the bottom number goes outside the radical as the index. Top in, bottom out. Same thing for a to the 4/5. So you put a in the radical, the top number goes in, the bottom number goes out. And so I think the first couple problems actually in your homework involve just doing this translation. So you just got to be pretty careful. Try not to make you dizzy here as I'm kind of zooming around the page. But let's try a couple more. So the negative sign is not in parentheses, so just kind of keep in mind that that means your negative is just going to be hanging out on the outside of your problem the whole time. So the x goes on the inside, top number goes in, bottom number goes out. Okay, and then the 5y, all that stuff is in parentheses, so that means that all of it is inside the radical. Top number goes in, so there's a 1 here, which means you don't really even have to write it. And the 2 just means a normal square root, and you don't write the 2 either. Okay, big difference between this example and the next one. Keep in mind the 1/2 exponent is only on the y. So the 5 is going to stay in front of your problem, kind of like that negative sign in this example did. The 5 stays, and then you just put a y in the radical. And it's just a 1/2, so it's just what I like to call a normal radical. And then last one, we've got some stuff in parentheses, so I'm going to put all that inside a radical. And the top number goes in the radical. I'm going to put parentheses around it because the 2 is going to everything in all that parentheses. And then the bottom number of the fraction goes on the outside. So that, my friends, is how you translate between those two different languages. Okay? And you can do a couple more practice by converting into exponential form. So right now they're all in radicals, and you have to go backwards and put them in fraction form. So what that's going to look like is you take what's inside the radical, and the top number is on the inside of the radical, so there's just a 1 on the top, and the bottom number is the outside number or the index, so a 3. Okay, so I'm just constantly thinking top number in, bottom number out. Same thing here, the x, and we got to turn it into a fraction exponent. So the top number is what's on the inside of the radical, the bottom number is the index. Okay, so that's all we're doing here. So I've got 4x to the 5th, which is going to be written as 4x to the 5th, and all of that stuff is underneath the radical that has a 7. Okay, so this is all we're doing. So remember, like, the top number goes in, the bottom number goes out. This one's a little bit more confusing because it's not a 7 exponent. Remember, it's a 1/7. That's what makes it the radical with the 7 as the index. And the 5 is a little bit confusing, but we just have to leave it like this because the 5 is only on the x. So that's why it's not to the 5/7, because that 4 doesn't have an exponent of 5 on it. So I'm just going to leave this one like this. All right, and this last one here. Let's see, we've got a 2 going to everything on the inside, and the index is a 3. So what I'm going to write is I'm going to keep the parentheses. I'm going to write 4x minus 1. And the top number goes inside the radical, and the bottom number is the index. Okay, and everything's in parentheses there, which means the 2/3 exponent is for everything that's in there. That x to the 5th example is a little bit different. Okay. All right, let's see what's next. Simplify. Now we are simplifying some. We're not going to do all of these. I'm just going to breeze through a couple of them to see if you guys can kind of get the hang of it, and then we'll save some of them for warm-ups for tomorrow. But I just kind of want to give you a general idea of how to break these down. So this very first example, remember, this 3 is super important. That means that when you're breaking down your radicals, you are circling a group of 3. So what I'm going to do is break down the 27 like normal. You know it's 9 times 3, and 9 is 3 and 3. So what I've found here is a whole group of 3, which is going to come out of the radical. So I'm going to write my answer down here. I'm going to write a 3, which represents that group of 3 that's coming out. And I'm going to leave a little bit of space and then keep my radical the same. I don't have any numbers left over, so there's not going to be a whole number inside the radical. But the way I want you to kind of think about this 5 here is I'm going to kind of break this up just to kind of explain here. You know that x to the 5th means that there are 5 x's under there. And so because of the 3, the index of 3, that means that you can only circle a group of 3. So you can see that there are 3 x's here, and that is going to come out, and so I'm going to write it next to the 3 on the outside. But can you tell how many x's are left over on the inside? There's 2 of them. And that's not a whole group of 3, so those don't get to come out. So those have to stay on the inside as x squared. Okay, and this is our final answer. So it's kind of like breaking down radicals, where it doesn't break down perfectly, but you're going to have a lot of variables in your answers as well. Let's try the second one. The fact that this is a 4, means that we can only circle a group of 4. So I'm going to start by just breaking down the 16. It's 4 times 4, and you know that those break down even more. 2 times 2, 2 times 2. There is my whole group of 4, and that gets to come out. And again, there's no whole numbers left on the inside. So I'm going to start setting up my answer. The 2 comes out. I've got a radical with a 4 in front of it. That radical has to stay the same the whole time. So to do this kind of the long way, some of you might be able to figure out this x to the 9th already, but I want to kind of write it out one more time. There are 9 x's, 3, 4, 5, 6, 7, 8, and 9er, and we're circling groups of 4. There's one group of 4, there is another one. So both of those actually get to come out of the radical, so I'm going to write it as x squared, and the x squared represents the 2 groups of 4 that are on the inside. And you can tell how many are left over on the inside. There's just 1, so that is our whole answer. And just as kind of a caution for you, make sure that you continue to write the index in your answer, particularly in Math Excel, because even if everything is right, if you forget to put the index for the radical, the whole problem is wrong. So just keep that in mind. It's really important, and it stays through the whole problem. Okay, we'll save those last 2 for examples for the morning. Do kind of want to talk to you about this box down here, though. Let's see the index, which you now know what it means. It is the number in front of the radical. Hey, if it is an even number, so kind of keep in mind just a normal square root, a 4th root, a 6th root, an 8th root. The radicand has to be positive. Do you know why? Meaning the stuff on the inside of the radical has to be positive. That's because if you square root negative stuff, you're going to get imaginary numbers, right? So if it's negative, we are going to have a non-real solution. This is something that you probably already know or probably kind of understand now that I mention it. So what about if the index is odd? Meaning if we have a cube root, a 5th root, a 7th root, a 9th root, or anything else. Remember how you can take the cube root of negative numbers? Remember how that negative sign just kind of goes out front? So that just means that the answer that you're going to have is going to have the same sign as what's on the inside of the radical. That's what radicand means, the inside stuff. So if you're cube rooting a negative number, your answer is going to be negative. If you're cube rooting a positive number, your answer is going to be positive. So just kind of keep in mind that's a little bit of a generalization for you. Okay, do want to do just a couple more examples, and then we will talk about questions and answer some other problems and issues tomorrow. Okay, so hang in there with me for 2 more, and then we'll get going. All right, if you notice, both of these radicals in this first example are square roots. So what that means is that you can combine them since they are the same. It's kind of like having like terms. That's what I wrote up here. Since they are both square roots, normal square roots if you will, that means that you can multiply them together and put everything underneath one radical. So we're going to do a 6 times 8 is 48. X to the 3rd and x to the 8th means x to the 11th and y to the 5th. And now we're going to break down all that stuff like normal, and we're just looking for groups of 2 here. So what I'm going to do is break down the 48 first. You know it's 6 times 8. There's other combinations, but you'll end up with the same answer if you used a different combination or different multiples. And so I'm just breaking down the 48. And again, I'm just going to circle groups of 2. So here's one, and here's another one. So my final answer, I'm going to get it set up over here, is going to have a 2 times 2 on the outside, which is 4. I'm going to have some stuff left over on the inside probably, so I'm going to leave myself a little bit of room. And you can tell that the 3 didn't get circled, so that has to stay on the inside. All right? Now let's talk about x's. So you don't actually have to line up 11 x's. Think about how many groups of 2 are in 11. If you would line them all up, how many groups of 2 would you circle? You would be circling 5 different groups of 2. Because 5 different groups of 2 makes 10 x's, and I have x to the 11th underneath, which means that there's 1 left over that didn't get circled. So you can kind of start doing that in your head. Again, remember, you've got 11 x's here, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is what you're thinking in your head. Group of 2, group of 2, group of 2, group of 2, group of 2. There are 5 groups of 2, which is why I wrote x to the 5th on the outside, and there's 1 left over on the inside. So hopefully by the end of this, you'll be able to kind of think about that in your head. Let's do the y to the 5th. How many groups of 2 are in 5? There are 2 groups of 2, and there is 1 left over. So this, my friends, is our final answer. Okay, and in this case, remember when you're typing into Math Excel, you're just using a normal square root here. But if it's a different square root, or if it's a cube root or a fourth root or anything like that, then you need that index when you type your answer. All right, let's see. Let's do one more. All right, these are both cube roots. So what we're going to do is we are going to combine all of this stuff into one ginormous cube root. And we're going to do 3 times 36, which is 108. And we're going to do x to the 5th and x to the 8th, which makes x to the 13th. Okay, again, we're going to break down 108. And hey, didn't we just multiply 3 and 36? So I'm just going to use those. And then 6 and 6. Okay? Don't have groups of 3 yet, so I'm going to go 3 and 2 and 3 and 2. So I broke down the 108 all together, and I'm circling groups of 3 since my number in front, my index, is a 3. So you can see that the 3s, that makes a group of 3, so that actually gets to come out. So when I write my answer, I'm going to put a 3 on the outside, and I'm going to give myself a little bit more room here. I'm going to set up my radical. Can you tell what was left on the inside? There's this 2, and there's this 2. So whatever's left over or whatever comes out, you always multiply. So 2 times 2 is 4. Okay? Now for the x's, can you think about groups of 3 that are in 13? So if you line up all 13 x's and you circle groups of 3, what you're doing is you're just dividing 13 by 3. So you get 4 groups of 3. That makes 12. And there's only 1 lonely x left over on the inside. So there we go. Okay. So that is going to be it for today. We will save, I think there's 4 problems that we'll kind of talk about in class tomorrow, but go ahead and try and just see if you can process this. Think about it a little bit, and I will answer all your questions tomorrow. Thank you for watching. See you later.